Okay, revision time. And let's be honest, trying to remember the difference between elements, compounds, and mixtures can be a real headache, right? Well, you're not alone. But don't worry, in the next few minutes, we're gonna get this sorted once and for all. Let's do this.
Yeah, this one. This is the biggie. You see something, it looks like it's all mixed up, but is it a compound or a mixture? Are those little particles chemically stuck together, or are they just hanging out? By the time we're done here, you'll be able to spot the difference a mile away.
So here's the plan. We're going to break it down into the three main types of matter you absolutely need to know: elements, compounds, and mixtures. We'll start with the basics, then build up from there. Easy.
All right, first up, elements, the ultimate building blocks.
So let's start with a question. If you could break everything down, I mean everything around you, into its simplest possible form, what would you be left with?
That's an element. It's a pure substance that no matter what chemical reaction you throw at it, you can't break it down into anything simpler. It's the end of the line. Think of things like oxygen, or iron, or carbon. They're kind of like the basic Lego bricks of the entire universe. And the best part? We have a home for every single one of these elements. It's called the periodic table. You can think of it as the ultimate cheat sheet or catalog for all the basic ingredients of reality.
Now, when you look at the table, you'll see it's basically split into two big groups: metals and nonmetals. They're pretty much opposites. Metals, they're usually solid, shiny, and great at conducting heat and electricity. Nonmetals, not so much. But chemistry loves a good exception, right? Take mercury. It's a metal, but it's a liquid at room temperature. How cool is that? Okay, so we've got our elements, our individual Lego bricks. What happens when we start clicking them together? Well, that brings us to our next topic: compounds.
So what exactly happens when elements combine chemically? And that word, chemically, is super important. We're not just talking about stirring them together in a bowl. This is something much, much deeper.
They form a compound. A compound is a pure substance made when two or more elements are chemically combined. And here's the other crucial part. It's always in a fixed ratio. Think about water, H2O. It's always two hydrogens for every one oxygen. Always. You can't just throw in an extra hydrogen and still call it water. That ratio is locked in.
Let's walk through how this works. You start with your separate elements, right? Let's take sodium and chlorine. Then a chemical reaction happens. This is the magic moment, often with some energy like heat or light, and poof, you get something totally new. A new substance with completely new properties, like sodium chloride. You probably know it as table salt.
And this is probably the most mind-blowing part about compounds. The new substance has properties that are completely different from the elements that made it. Seriously, think about it. Sodium is a super reactive metal that goes crazy in water. Chlorine is a toxic gas. But when you chemically bond them together, you get salt, the stuff you put on your chips. It is a complete and total transformation.
Okay, we've got elements, the building blocks. We've got compounds where they chemically transform. So what's left? Mixtures. And this is where things get mixed up, but without all that chemical drama.
So this brings us to the classic question that trips everyone up. How is a mixture different from a compound? Let's get this straight right here, right now, so you never get it wrong again.
Okay, let's look at this side by side. In a compound, the elements are chemically combined. A brand new substance is formed. Think of it like baking a cake. You can't unbake it. You need a chemical reaction to separate it. But in a mixture, things are just physically mixed. Each part keeps its own identity. Think of a salad. You can still see the lettuce, the tomatoes, and you could totally pick them out again. It's just a physical separation. That's the core difference.
But wait, there's more. When it comes to mixtures, there are a couple of different types. Let's dig a little deeper into solutions versus suspensions. So, are all mixtures the same? I mean, think about it. If you stir salt into water, it disappears. If you stir sand into water, it just swirls around and then sinks. Both are mixtures, but they're obviously not the same. Let's look at what's going on.
So on one hand, you have a solution, like salt water. The stuff you're adding, the solute, dissolves completely. The particles are so tiny you can't see them and they'll never settle out. Light just shines right through. On the other hand, you have a suspension. Think muddy water. The particles are insoluble, they're just suspended. You can see them, light can't get through, and if you just wait, they'll all sink to the bottom. See the difference?
All right, time for the final showdown. Let's put everything we've talked about side by side to really lock it in for your revision. Ready? Let's do a super fast recap. Element, the simplest pure substance. You can't break it down. Compound, Elements chemically bonded together in a fixed ratio. It forms a totally new substance, and you need another chemical reaction to break it apart. Mixture. Substances just physically jumbled up. No new properties, and you can separate them with physical methods. Bam! That's the whole thing in a nutshell.
Okay, here's a final challenge for you. Right now, wherever you are, just look around the room. Can you spot one of each? Can you find an element, a compound, and a mixture? Come on, give it a try. Once you start looking, you'll see that chemistry is absolutely everywhere.